Ratios connect to the statistical tools we use to make sense of data or make sense of a movie or make sense of the world around us as we're interested. So the mean is a measure of center that we often rely on to make sense of a large data set. When you have enough data points, the more data points you get, the more the data often tends to a center point, and that's why it is helpful. So if you look at data tending to center, maybe there's just a video or a clip. That's not what I'm looking for in terms of seeing some strange images, but I'm just thinking about law of large numbers, and as you have more and more data points, the more likely the data is going to be towards the middle. So you see here, this is a histogram of a symmetric continuous data set. It's peaks in the middle. The mode and the mean and the median are all pretty close. Here, this is a categorical data. You can only find the most common. You can't calculate median or mean. This is a skewed continuous graph of data, meaning that you can have parts and the mode is way to the left. That means the mean is not going to be super representative of this sample. The mean is likely going to fall somewhere around here, and the median here, and the mode here. So when you have a skewed graph, it doesn't always make sense to use the average or the mean. So let's go back to this. When we have symmetric data that is not categorical, that is actually numeric or continuous, even if it's discrete, meaning you can only count it, you have to be careful. But if we're calculating the mean, trying to find a typical value in the middle of a data set, then it's important to make sure we understand rational numbers and integers, especially the measure of spread that can be associated with mean is called mean absolute deviation. That's helping us understand how spread out the data is. Remember, I like to refer to butter spread on toast and then also like a slice of butter on toast. So when you think about this image, this is data that's not very spread out. That means that the measures of spread, the mean absolute deviation, the standard deviation, the interquartile range, these are all terms that we'll get to know. The measures of spread will be close to zero when the butter is spread out evenly. That's a uniform distribution, meaning it's all spread out the same, and that looks like this. Uniform distribution. It's just going to be sort of flat all the way across, a uniform distribution. And then a normal distribution as butter. Let's see if somebody's been clever enough to come up with that image. A normal distribution. Now is a good time for you to be taking notes in your student copy while I'm searching something up or pausing. That's a good time for you to take notes. And a butter on toast. I don't know if somebody's been clever enough to make it, but somebody should. Let's see. Do any of these look like a normal distribution of butter? Sort of like a mountain, a sloping in the middle, not really. So maybe that would be a cool meme to make, or maybe like this. Yeah. So like there's a big clump in the middle. I like this. So this is more normal because there's a lot in the middle and then it's distributed evenly as it goes off. Anyway, I digress. Going back to these slides. So what you might want to write here in your notes is that the mean and the mean absolute deviation are measures of center and spread that require understanding ratios. If center is the mean, and then the measure of spread is the mean absolute deviation, which we'll learn more about later. We talked about the butter analogy or imagery, butter on toast. Images for spread and center, but mainly spread. Getting to know spread, and then why do we need Ratios. Well, we need ratios because when we calculate the mean, you're comparing the sum. I guess I should ratios used in calculating the mean. Calculating mean. Because you take the sum of all the values and you compare it to the count. It's a ratio. And then you can use it to get a unit rate of the total sum divided by the numeric count is if the data was distributed uniformly, how much each data point value would hold. So if every value had the exact same amount, that would look like taking a single number on a histogram. So a histogram with no spread with standard deviation equal to 0. Okay, something close to this. The one in the middle with the standard deviation closer to 0. It's like if every value was the exact same, all you would have is a single peak of frequency in a histogram going up to that center. But anyway, that's not the case. We're just pretending that, oh, that's a recording. Okay, so then we'll go here. It gives us a unit rate of the average value per 1 unit of whatever you're measuring. Okay, so I don't know how my notes came out to you, but this is the whole process of understanding math, is like taking notes about what you hear. So let's continue on. Here we're looking at now, let me just grab this one as I've been using it. Looking at the mean beyond a ratio. Ratios are important in terms of our number system because there's a whole world of numbers called rational numbers. And if you look at the root of that word rational, it means that it's a ratio. And then there's irrational numbers. And irrational numbers come into play when you think about squares and the distance between the opposite corners of a square. The diagonal of a square, this roots back historically to the Greeks, and Pythagoras and his school and students often take credit for this, but if a square has side length 1 and side length 1, obviously it's a square, then the distance of its diagonal would be the square root of 1 plus 1, which is 2. And then this value, there is no number that is a rational number that you can multiply by itself to get 2. So the square root of 2 is called irrational. And it's the world of square roots. But I mean, some square roots are rational, like the square root of 4 is rational because it's 2 times 2 equals 4. So the reason I'm digressing into that world is helping you all see where we are in the number system when we're working with means. It's ratios, they're friendly, we can multiply, divide, we can use addition, subtraction in certain ways. We have to be careful about how we're using addition, subtraction. Mean absolute deviation uses absolute value when we're trying to figure out how far away a data point is from the center. If it's to the left, it has a negative distance, but it's not important. So we use absolute value. We're not worried about which direction of the data set a certain value is on. We just want to know how far it is from the center when we're trying to measure spread. So absolute value is important. And for absolute value, we need negative numbers, and negative numbers live in the integers. Okay. So the whole numbers live with 0 lives with the whole numbers and with integers and with rational numbers. The integers are the whole numbers and their opposites. 0 doesn't have an opposite because it's that reflex point. It's the symmetry point in our number system in the real numbers. If you are interested, you can reach out and expand to standard deviation. Just send me an email. I'll give you a resource to kind of explore that on your own, but it's also just a way of measuring the spread of a data set. So looking at these data sets, seeing all the different standard deviations, you can play around with standard deviation calculators. Google search, let's see, standard probability distributions. I mean, we can go around looking at different different models to make sense of how spread out data is and how close to the center it is or how far away from the center it is, what the shape of it is, what's the behavior, when should we use mean, median, etc. Okay, back to your notes. So here you could talk about the idea of we still need ratios, but then ratios can become complex ratios involving square roots and sums of areas. So instead of like with mean absolute deviation, what we're going to really focus on understanding and try to learn really clearly tells us how far away any data point is from the middle of a graph. But with standard deviation, you take that distance and square it instead of finding the absolute value. So that's interesting. It's another way to getting a positive value. Absolute value takes any negative or positive, turns it all positive. Same thing happens when you square a number. So you turn all your values positive. That way none of them cancel each other out, which is pretty cool. But then to bring them back into distance, you eventually have to take the square root. So these are just applications of all of the really cool operations and relationships that we have in mathematics and directly relating it to the statistical tools we can use to make sense of the world around us. Finally, median. I love median. You get the 5-number summary, which is the minimum and then the maximum. And then in the middle of the minimum and the maximum is the median. And then in the middle of the minimum and the median is quartile 1. And in the middle of the median and the maximum is quartile 3. And median is technically quartile 2. So in that, it allows us to find centers and looking at spreads of data by ranking, essentially, looking more at like the order of data points and like the lower 25%, the upper 25%, the middle 50%. And it also allows us to see center and skewness. So a box and whisker plot allows us to see the center and skew. I like this little graph here. You get the interquartile range, shows you how much, what the middle, what's the range of data points for the 50% of data. So the smaller it is, the closer it is to the middle. And this is comparing sort of histograms and box and whiskers, how they might appear and might show up. Left skewed, remember left skewed has a tail to the left, right skewed has a tail to the right. Here's this, I really like this one though. It shows like what's in the middle 50%, what's in the outer 50%, what's considered an outlier, how you get that outlier limit. So Google image searches are great. Okay, so you could add more there. And then you also can take time now to add notes to the number system, design your notes about our number system. So I might talk about how square roots open a new world of irrational numbers. I might say that squaring numbers makes the value positive, just like taking the absolute value of a number turns the value positive. Be aware that squaring numbers moves into the second dimension and that it makes sense to eventually take a square root to return our measurements to one dimension, which is distance, since we are talking about distance from the center when we refer to the spread of data. I would really recommend practicing doing just what I did, just like speaking out loud and typing what you say. Okay. So I'll move on to the next video in a moment, which will explore more about the different types of numbers and then sort of summarizing the lesson.